Good morning. Can you hear me?
Yeah, we can hear you.
Yep.
Okay.
Yes.
Okay. I'm late a minute or two because I started Zoom and it decided to update itself. And let's see. Haven't used this in a while. I'm trying to remember how everything works. Okay. You should see my desktop. Is that what you see on your screen right now?
Yeah.
Okay.
Yeah.
Yeah, that's what we'll do. I'll just use the desktop like a projector screen in class, and we'll look at code examples running on this computer here at home. Okay. And oh, one important thing is I don't really know. I don't see you. So if anybody has a question anytime during the class, just unmute yourself and talk. Just interrupt me. So please feel free to interrupt anytime if you want to, if you have a question. Because if you use the little flag thingy or you try to send me a message by chat, I won't really probably notice it. It's too, while I'm talking, it's too hard to notice the chat icon and little flag icons. So if you want to ask a question, please just interrupt. Okay. And let's see. Okay. So here's the website for today. Uh, the, the most important thing I want to show you right now is I've got the README for Renderer 2 finally up as a website. So it's a lot easier to read and work with right now. So here's the README that this discusses what we've been talking about. Um, everything but the last section is written. So the stuff we haven't started talking yet about model view controller, but this part here is real sketchy. It hasn't been written yet, but the other parts have been written. Um, right now we're in the middle. We're in this part here called uh, creating no Java's event handling method. So that's what we started last Wednesday, and that's what we're going to pick up today. We're doing this section on Java's event handling method. Okay, and what we want to do today is talk about this picture here. Okay. And we're going to use these code examples. If you go back to the website, we're using these examples here, and I've updated them over the weekend. So they're if you downloaded it last week, download the zip file again because it's got some new examples, and I've cleaned up some bugs that were in some of the examples before. Okay, so I've got that folder here. Okay. Okay. So what we're going to do is we're going to do the examples that are in this simple examples folder. Those are the easiest examples we have of event handling code, and then we'll look at some of these other folders that have more complicated examples. Okay, so let's go back to the README. Oh, let me just show you real quick. Um, no, okay. When we write event-driven programs, we have to have three kinds of objects. That's what this picture is showing us, is three kinds of objects. Well, actually, let me, okay. Remember, this other picture, we talked about this the other day. Java's GUI system can divide into five different kinds of classes. This is a real basic idea that there are these five kinds of classes that make up the whole library of GUI programming: components, containers, layout managers, events, and event listeners. Okay, last week is what we talked about these three things, which are these are the names of those classes in the Java library. Components are things like labels, buttons, checkboxes, drop-down lists, menu items, text areas. Components are the things you build a GUI out of. Okay. But you organize the GUIs into containers. Like up here, there's a container across this top that holds these tabs. If I click on one of these tabs, there's a container over here that holds these menu items, or this table of contents. And there's a little container over here, and there's a little container here. And if you look at almost any GUI, for example, if I open TextPad, when you open TextPad, you see lots of containers. You know, the title bars. See, this is a container holding all these buttons. Then this is a container holding all these menus. Remember we showed in class that you could take these containers. Well, if you scrunch this, you see how this container is actually using what the next idea is. That container is using a flow layout. See, you see how the menu items flow down. So that container is using the flow layout manager. So we put all the components into containers and we give the containers layout managers that arrange them. Okay, that was the beginning of the GUI stuff. Building a GUI without worrying about what it does. Oh, notice that there's a kind of an interesting difference between containers. This container here and this container here don't act the same way. Okay. This container, the one that holds the menus, flows when you shorten it. But the container above it that holds the buttons just gets cut off. Notice it doesn't flow. Okay, why did the designers decide that? I don't know. You would think they'd make them both flow because when you do this, you don't see any buttons anymore. You know, and so you could lose your buttons by making your window a little bit smaller. Okay, but the menus, they're always there. Even if you make the window smaller, the menus make sure that they're still visible. Okay, what they did is they used a different layout manager in one of their containers. They used the flow layout in one of them and one of these other layout managers in the other container. So that's the visual part of GUI programming is arranging these components, containers, and layout managers. Now we're going to start talking about these other two, the events and the event listeners. Okay, so in this picture here, this is an event listener and this is an event. Okay, so we're going to show the relationship now between GUI components, which were the first, you're always talking about components. Components are the things you put in a GUI. Those are the things you click on. Okay, like over here, the components are these menus, these buttons, this panel over here, the tabs over here. If I create a new tab, the you click on tabs to see what's in them. This big window here that I'm typing in for the text editor just is a component. In fact, it's one of these components called a text field or a text. Actually, it's probably a text area. Okay, that's just a component. From the GUI's point of view, this little button here that I click on is a component, and this big area that I type in is also a component. In a text area, the majority of the window is taken up by a text area. Okay, so we want to start talking about these two and tie them back to this one. The containers and the layout managers don't have a whole lot to do with events. The events come from the components and are sent to the listeners. Actually, that's what's described in this section here on Java's event handling model. The key idea to remember is events start at components. They get sent to event listeners who are listening for them. The events are the things that are sent from the components to the event listeners. These are essentially messages. When you click on a button, a message gets sent to an event listener. Okay, that's the object-oriented programming point of view. Okay, you click on a button, it sends a message to the event listener who handles the message and does something in the program. Okay, the when you have somebody sending a message to somebody else, there has to be somebody who sends the message, and that's where the Java Virtual Machine comes in. We kind of talked about that last Wednesday. It's the Java Virtual Machine and the operating system who notice that you clicked on something, and then who send and build this message containing the information of who you clicked on, and then pass that message to the listener. Okay? So over here, this is a picture of what it looks like. This is the component that you would click on. Okay. It has a list of objects over here that are the objects that are delegated the responsibility of handling his events. So this would be a button, for example. This would be an object that represents a button. A button needs to tell Java who's his delegate. Remember, Microsoft actually calls these objects over here delegates, and that's a real good name for them. The object delegates to these objects the responsibility of handling what happens when you click on them. So a button delegates to a button listener the responsibility of handling the events that come from the button. The operating system picks up the event when you click on the button and sends it. The operating system then looks in this list to see who it's supposed to send the message to. Right. So let's pop up an example of this. But the example is going to be this picture here in code. Okay, so the examples are in this folder, Java GUI events, which I've already downloaded and unzipped on this computer. Okay, so I here's the folder, and the simple examples are in this folder here. Okay, so we did this example in class on Wednesday. Let's just look at it over again. This is uh, this is the example we were looking at in class. Okay, let me compile it and run it. Okay, see, there's the button. That's the component. Click on it, and there's the response to it. Okay, there's the message that was sent from this button to the event listener. The operating system the operating system and the Java virtual machine together built this message. That's the event object. Okay, so yes, the java.awt.event, and it's a specific kind of event object. It's an action event. If we go back over to this table, see if I can find it. Nope. See, in this table, we have events. We're looking at, see, action event. So you can see we're looking at an action event. And this table tells you that action events can come from buttons, combo box, lists, radio buttons, text fields. See, these are the kinds of components that can send that kind of uh, event message. Okay, so these are all the each kind of component sends a different kind of event message. So each kind of component has its own kind of event. So, for example, checkboxes send item events. Okay. Notice that combo boxes actually send two, every time you click on a drop-down list, at least in Java, it sends both an action event and an item event. So combo boxes send two kinds of events, and lists do the same thing. Lists send action events and item events. And we may not go into that much into the details of this. If you like want to read a book on Java GUI programming, or if you get really deep into HTML style GUI programming, you start learning a lot like why did they divide? Why do they have combo boxes sending two kinds of events? And it makes for a real versatile programming style. There's reasons behind it. It's not doesn't make things easy, but it does make it real versatile. So it's not unusual for an a component that when you click on it, it issues several kinds of events. Each kind of event carries a different message. So your program could respond to the action event from a combo list and not care about the item event. Or the other way around, it might be more interested in the item event, or it might look for both of them. We say they have different semantic content. The item event says something a little bit different than the action event. So when you click on a list, if you're interested in certain kinds of information, you pay attention to the item event. If you're listening to other kinds of information, you might pay attention to the action event. If you want to know everything about the list, you might need to listen for both kinds of events. Okay. But right now, we're working with a button, and the button gives us an action event. So over here, this guy is a button. This guy is an action event, and it's being sent to an action event listener object. Okay. So over here in the program, you click on the button. Every time you click on the button, oh, notice, oh, it froze up. Okay, let me start it over again. I'm not sure why it froze up. Every time you click on the button, you get a different event. No, remember, the program's not doing anything right now. The program is waiting for events. And it's actually the Java Virtual Machine is doing the waiting. The Java Virtual Machine is running this program. And the Java Virtual Machine right now is waiting for me to click over on something. And when I click over here, the Java Virtual Machine realizes I clicked. For example, if I click down here, nothing happens. Actually, quite a bit happened here. When I click down here, the operating system told the Java Virtual Machine, you got to click on one of your windows. When I click over here, the operating system tells TextPad, you got to click. See, that event caused something to happen in TextPad. The operating system saw the click over this window, said that window belongs to TextPad, sent a message to the TextPad program. Over here, when I click on this window, the operating system says, oh, that click happened on a Java Virtual Machine window. It sends a message to the Java Virtual Machine. The Java Virtual Machine noticed that it has no components sitting under the mouse right now. So the Java Virtual Machine ignored the message from the operating system. But when I click on here, the Java Virtual Machine says, oh, at that point on the window, there's a button object. I need to send a message to the button handler. So then you're back to this picture here. The operating system created the event, sent the event to the operating system created the event, sent the event to the Java Virtual Machine. The Java Virtual Machine realized that when the mouse is over here, it's over a button. So then the operating system went to the button object because it knows it's which object is it owns that little real estate. It asked the operating system for its list of event handlers. It got the reference to the event handler object, sent the event message to the event handler. Okay. In the code, yeah, we do that by yeah, it's this stuff is kind of tricky. There's a lot of things going on. In this case, there's the running program, the the visual concept of how the objects are related to each other, and then there's the code itself. Again, we're working with a projector. It's kind of hard to see all these things at once. If you're at home, you really should kind of have this documentation up, this running program up on your screen, and this code up on your screen. And hopefully you have more either a big enough screen or two screens. And you have to kind of think about you have to go back and forth between them. How does this code relate to this picture, relate to this running example here? Okay, so this guy is the button. This guy, well, yeah, we have a fourth window. Remember, we have the output window from the running program. Okay, so I've actually got four windows that I'm watching at once to keep track of what's going on. Okay, not this one here. Okay, but I got four windows. The program is running here and here. This documents it, and this is the actual code. Okay, I click on a button. Whoops. I click on a button, I get a message over here. The button is this guy. When I click on him, the operating system says, you clicked on this button. He finds out who the event handler is. He builds this message and sends it to the event handler. The event handler we wrote just does nothing but print that message to the console window. Okay. Over here, where is it? Here's the creating the button object and making him part of the GUI. So remember, you not only have to create the button object, but you got to add it to the GUI. You have to make it part of the scene graph tree. The J frame is the root of a tree. And that's, there's an example up here. We did it in class last week. You know, we're building trees. So when you design a GUI, just like in the render, you're designing a tree. The J frame is at the root of, now right now we have a real simple tree. The J frame is at the root of that tree, and there's only one button in the tree. Okay? There's the layout man. See, there's the J frame, that's the root. We create a layout manager for the J frame. That's this node here. Then we add a button to the list of components. So right now we have just one, two, three, four. We have this button here. We have a J frame with a layout manager, a list of components, and in the list of components, there's just one button. So we got a simple version of this tree. Okay. Notice there's lots of ways of thinking about this stuff, lots of different pictures. Over time, you start getting a natural feel for going the fact that this code's building a tree. That's the picture that was up here. The fact that the code is building a tree, you know. But then the code sets up this set of references. The button points to its event handler. Okay, so the frame with a layout manager holds the button. The button was added to the tree. Then here's the part that creates this guy here. Okay. We tell the button to add an action listener to himself. That's this list here. We're Remember, add always adds things to a list. See, when you see add, you're always adding to a list. This add is adding to the J-frames list of components. Go back up here. See, the J-frame has this list of components. Okay, that's what this is adding to. Adding to the J-frames list of components. Like I said a minute ago, you get used to this, but I'm going through it in real, maybe feels like painful detail, but eventually, when you read this code, you just have to see these pictures in your head. That's when you're like a real fluent Java programmers. You see this code and you just realize, yeah, that's adding to the J-frames list of components. So that's building the scene tree of the GUI. Okay. On the other hand, this is adding to a different list. Okay, that's down in this picture here. Okay. The button object, the button component, has a list of event handlers. Who's responsible for responding to the button's events? Okay. This is the list of, by list, it means you could have several event handlers. A button, when you click on a button, can actually cause several different things to happen at once. There can be several different event handlers. Right now, we're just emphasizing one, but there could be, actually, it's not that unusual in sophisticated GUI programs for a component to fire an event and it be sent to a bunch of different handlers. Okay, so right now we're adding to this list one action listener. Okay? Just one. If you don't have any in here, then you click on the button and nothing happens. Okay, you can have a button on the screen and the button can have no listener objects, and then when you click on the button, nothing happens. If you have at least one listener object, then whatever that listener object does is what the button does. Okay, so here we're adding an object to that list. Now, what object are we adding? Well, we built it over here. It's a new button handler. Well, what's the button handler? Well, that's this class down here. Now, see, notice that this picture says a button handler event holds a event handler method. Okay. See, there's literally this picture here is what you think of in memory, but that's the code here. I have a class that defines an object. That object holds only one thing, a method. See? So this object holds a method. Here, you gave it a generic name. It's an handle event method. Well, that's kind of a made up name. That's just kind of a generic made up name. See, here it's every one of these different kinds of events has a different name for this method. Here it's action performed. Okay. We'll see that each event handler has a different funny name for this event handler method. If you go back to this list, every one of these event listeners, where are they? Oh, yeah, I'm sorry. Every one of these event listeners has a completely different name for the method that is its event handler. In fact, some event listeners have multiple methods. Like mouse listeners have 5 methods. There's lots of things that a mouse listener can do. Um, A window listener has 7 methods. We'll get to the window listener a little bit later. Window win, a window represents these kind of a top level window like this. They have 7 different things that they listen for. Okay, a mouse listens for well, actually a mouse also listens for 7 different things because they divide mouse clicks from mouse motion. So mouses can generate 7 different kinds of events. So there's 7 kinds of event listeners. Buttons are simple. A button generates one kind of event. It's an action event, and the method is that handles the action event is called an action performed. Okay. The This kind of funny that they use the past tense because uh, this method isn't in the past. This method is what yeah, it should have been action perform. I don't know why they made it in past tense. This is what performs the action. Okay, if you go back over to this picture, this is the method that performs the action that handles this action event. Not sure why they gave it past tense because it's kind of confusing. It's not something in the past. It's something when you click on a button, then this thing gets called. So it's the thing that handles the event. Notice that we have 1, 2, 3. We have new button. That's this corner over here. We have new button handler. That's this guy over here. And we get the third object here. When this method is called, here's the third object, the action event object. So we have the button is the source of events. The button handler handles the events. When you click on this button, there's a message sent to this handler, and there's the message, the action event. Okay, a little bit tricky. I mean, I think this picture tied to this code starts to give you a visual sense of where these things are, how they're intertwined to each other. It's object-oriented programming. It's all kinds of stuff is happening at the same time. You've got to build a mental picture of this compared to this compared to, this. Okay. All right. So over here, when we, over here, we build the frame object that starts our GUI tree. We add to that tree a flow layout manager. There's only one thing in this GUI, so we don't see the flow happening. But if there were 2 buttons, we would see the buttons flowing when we made the window smaller or larger. Okay, so we create the layout manager. That's just setting up the appearance. Notice we're doing things like setting size, setting location, making it visible. This is all appearance stuff. Okay, then we create a button. We add it to the GUI. So far, that's still just appearance stuff. We made the button appear. We haven't made the button do anything. Now we start handling, now we start handling event stuff. We create a button handler object. We create this object over here with the method that accepts the message of when a button click happens. We add the we add this guy to the list of handlers for the button. We could give the button more than one handler. Actually, we'll do that in a second. Okay. And we then the program, then our main method terminates. Remember we talked about this idea that after we create this GUI, this method terminates. But this when we made the GUI visible, we actually launched a second thread, and all this code over here is actually happening in this other thread. Okay. Now, actually, let me do this. Let me create a second button handler. Button handler 2. And let me add button handler 2 to my button. So I'm now going to put two things in this list. Okay. So I'm going to add button handler 2. Okay. Now I'm going to compile this. Okay. Run it. Okay. This is the new version running now. What do you think is going to happen when I click this button? Anybody? You know,
It's just gonna put out the events twice.
yeah. Because if you think about this picture, there's two event handlers. I'll close this one. There's two event handlers. The Java virtual machine goes through this list, sends the single event message to two handlers. Now they both do the exact same thing. See, they just did the exact same thing. Let's see, can I make them do something a little bit different? I can't make them do something a little bit different because they're two instances of the same class. If I wanted them to do something different, I can do this now, do something a little bit fancier. Create two different event handler classes. So this is button handler 2 class. Here I created two instances of the same class, so I couldn't really make them do anything different. Now I'm going to create, this is now an instance of the other class. Now I can make this guy do something different. Let's see, we'll have him just say, okay, he'll just print out a different message. Okay. So now I've got two kinds of event handlers. Let me close this. Not only are there two different event handlers in this list, but they have different types, so they can do slightly different things. See, did I do this right? I've got one kind of event handler here called button handler. Then I have the other kind of event handler here called button handler 2. I'm going to create an instance button handler 2 of button handler 2 and add it to the list. Compile it, run it. Okay. Now, when I click on the button, see? Oh, and what order are they done in? Probably the orders. Let's see. See if I can get them. Oh, does anybody want to guess why I did them in that order?
I'm guessing every time you add a handler, it probably adds it to like the top of the list. So
That would
then
be
when
my
it,
guess. Yeah, exactly. That'd be my guess too. And it just goes through this list in the order they're in. So when we added this handler, he ended up at the top of the list. That's kind of, that's not, Java actually has two different methods for adding to a list. One adds to the front of the list and one adds to the back of the list. And sometimes people use one, sometimes people use the other. More than likely, they're not starting at the bottom of this list. That'd be really kind of dumb. So they should start at the top of the list. So probably this add adds to the top of the list and pushes things. When you add to the top of the list, you push things down lower. The things that are in the list get pushed down bottom. So now we could reverse the order. create two button handlers and then put them in the list in, say, that order. Okay. Now we're adding handler 2 first, adding handler second. Okay. Compile it, run it, click the button, and now the messages are in the other order. It kind of looks like it's the Java virtual machine when it gets the Java virtual machine gets the event message. It gets this message. The Java virtual machine needs to deliver it somewhere. He asks the button, who are your handlers? The button says, here's my list of handlers. That's given to the Java virtual machine. The Java virtual machine just goes through this list in order, sends the message to each object in the list. And right now, our list has this second in the list and probably, this one first in the list. This one prints the event object. This one just prints a little message. Okay. All right. So that's the core idea. This is what people refer to as Java's event handling model. Okay. All we're talking about is, how do you get a method? How do you get an event fired? People use the word, we're firing an event and handling an event. We're not doing anything interesting. All our methods do is just show you what the event looked like. So we're doing event handling, but we're not really doing GUI programming because the real issue is that when somebody clicks on a button, it should cause something to happen in the GUI. See, we press on the button and something happens over here in the console window. We really ought to see something happen in the GUI, but we're not doing that yet. We're going to need to bring in more objects. We're going to need to bring in something over here that gets updated when we click on a button. That's actually the next section is event-driven GUI programs. The idea that you can handle events, but when you handle events, they ought to show up in the GUI. So this section 6 is just the event handling model. It's just this picture here. Okay. And then we're going to add a fourth, we'll see. The event-driven GUI programs adds another object to this picture, something that's going to get updated by the event list handler when you click on a button. But things start getting complicated, and then this starts getting pretty tricky. And then eventually what people did is they added a fifth object to the picture, and that's what's called the model view controller pattern. You take this picture and you give it a fifth object with what's called the state, and this helps people organize complex GUI programs. So you're juggling in your head 5 different kinds of objects. The event generators, the components you click on, the handlers for those components, these event objects that represent what happened over here, the GUI object that's going to get updated when the event happens, and a state object that kind of keeps track of everything that's going on. This picture here is what's called the model view controller pattern. Though I haven't finished writing this section. This section is real. Right now, it's real. It doesn't make sense. If you go read this, it doesn't really make sense because it hasn't been finished writing. I'll probably finish it today. Okay, so we're really talking about this section here right now. Just delivering the events from a component to a listener, and right now just printing the event. Okay. Now, if you read this section, it's a little bit different than what we're doing here. Over here, we were writing our code in a text editor. Okay. Over here, I point out you can do this. Let's do it. I'll just show you so you can kind of see what I'm talking about. To do this in the J shell, if you do it in the J shell, you get kind of a nice way of doing this coding. So let me close all these. Let's see. Okay. I think I got everything closed. Okay. Let's work in the J shell. Now, in the J shell, you need a J shell started up. It doesn't really matter where you are. Okay. I will just open a command window. Okay. See, I opened a command window on my desktop. Okay. Right for now, it doesn't matter where this J shell lives. Okay. Later on we'll see that you may want to create the J shell in a folder specifically. So for example, here's a J shell program. If I want to run that J shell program, then I need to create my J shell in this window. So you notice I'm in the simple events folder. I want the J shell to be in that folder. If I type J shell now, this J shell is in that folder. If I exit the J shell, I can restart it again, but I can restart it and run this J shell program. So I'll run that. I'm tabbing through there. See, there's my J shell program. The J shell is in this folder, so it has access to these programs. I can run that J shell program. Okay. See, it's a little bit slow. I'm not sure why my computer's running so slow. Boy. Okay, so here's the program running. See, it's a real simple little program. It's just, there's the whole GUI. Okay. Right. So I'm running now, but I'm still in the J shell. See, I can still talk. If I want to know what code just happened, I type list. Oops, wrong slash list. There's the code I'm actually running. That's the code that was in this file. Okay. So you can, if you have a J shell script and you want to run it, you open a J shell in the folder that holds the script, and then you go over here, slash exit. You, oops, you run J shell with the name of the script file. Okay. On the other hand, if I just want to type my own code into J shell, I can just open a J shell anywhere. In this case, it happens to be on the desktop. I start J shell, and now I'm going to type my own code into J shell. Now, if you go back to that README, what the README does is says, here's some example code you can type. Okay. So for example, the README says, take this code and copy and paste it into the J shell. So I highlight it, you know, copy. Then J shell lets you paste all kinds of code. So I can just I pasted it, okay, and it ran. Um, Notice, and it created a GUI. Now be careful here. This is the kind of little trickiness about this stuff. See, when I highlight this stuff, there's something missing here. See this last line? The highlight ends at that line. There's no carriage return at the end of that line. These lines all have carriage returns at them. This one doesn't. If you look at my GUI, you see that it's sitting at the end of, see, it's sitting at the end of that line. You have to hit enter one time to make that one line be executed by the J shell. So that's a quirk of, now, not a Mac might work differently. A Mac, when you do this highlighting here, sometimes when you control copy, sometimes this GUI will add a carriage return at the end of the last line. Sometimes it doesn't. Like right now, Windows is not adding a carriage return at the end of that last line. So when I pasted it, I needed to add my own carriage return. Okay. Now, if I go over here and I type slash list, I see the code that I just ran. It's this code that I pasted. See, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code. This is a real nice way to work. Um, whoops. Instead of working, this is actually one of the things that makes Python liked by a lot of people because Python people naturally work this way of just copying and pasting code into a text box, running the code, experimenting with it. Python script, all Python programs are Python scripts. In the case of Java, the majority of Java programs are these .java programs. That's what you're used to. The minority are Java shell scripts. But in the case of Python, every Python program actually is what we would call a script file. So it can be run as a program or it can be run in a command line like this. In the case of Java, we have both kinds of Python doesn't have these kinds of programs. In Python, everything is really a script file. In Java, this kind of program needs to be compiled into, I deleted, oh no, into a class file. You have to compile this into a class file to run it. The scripts are never, they're compiled, but you never see the class file. They're, they're not compiled into class files. They're literally compiled directly into memory. When you take this, when you take this script and you load it into the Java JShell program, JShell does compile things, but everything gets compiled directly into the Java virtual machine, and there's no class files created. Okay, so that's a slightly different way of doing things. But this is a real kind of nice way to do things. Now, if you look, what do? We need to import some stuff, just like in regular Java. We create a window. That's this guy up here. We create a window. We give the window a flow layout. We create a button. That's this guy here. We put the button in the window. The pack command makes it look nice. We set the size of the window. We made the window visible. And then here we did in a single line, we took a bunch of lines in our other code. This is the event handler method. This is the, whoops. This is this guy. If you look over here in this code here, that's called a lambda expression. That's a method. That's a real elegant, terse, simple notation for saying, here's the input to the method, here's what the method does. We say that the method sends that input to that output. Okay, so this is called lambda expressions, lambda notation. It's kind of a functional notation that says, here's the input, here's the output. Very elegant. Modern Java is making more and more use of these lambda expressions. They got the idea from lambda, from functional programming. Notice that this one line took the place of, let's see. Oh, I closed the text editor. Okay, kind of compare. There's a lot of things to compare. That one line serves the purpose of defining this button handler and adding it. See how this said add action listener? There's the listener. Here we have to say add action listener. We needed to instantiate the action listener up here, and we needed to define the action listener down here. This little notation, it's really kind of beautiful. This little notation got rid of this line of code, this line of code, this line of code, this line of code, and basically boiled it all down to that thing. See, it said take this event and send them here. See, he's the input, he's what you do. This function says, give me an event and I'll print it. But this function needs a declaration. That declaration needs to be embedded in a class. Okay. But this is all it's saying. And here they boiled it down to the core idea. What's the listener? A function that takes in an object and prints it. Okay. So here I got rid of this boilerplate that declared the function. I got rid of this boilerplate that instantiated the class that holds the function, and I can just say add the function. This guy down here. E goes to print. Okay. Right. It took years for people to it took many years for people to see all this code and boil it down to its essentially what you might call its essence of a lambda expression. Though the truth is, this lambda expression notation has been around since the 1950s. It's not actually new. The people in the world of functional programming were doing this way back even in the 1950s, but the C style programmers, the traditional programmers were doing this, while the functional programmers were doing this. And about 10 years ago, the Java people, the C++ people, everybody started saying, we really ought to be doing this. And Java added lambda expressions to its language. C++ added lambda expressions to its language. The C# people added lambda expressions to its language. The people in the more or less traditional world of programming started saying that these guys have a lot to say about programming, these functional programmers, and they've added this functional notation to their traditional languages. We don't teach it in our introductory courses, and that's actually how I hope going to change soon. I think the introductory courses should be teaching side by side with the traditional notation, this more modern notation. You get used to it. It's very elegant. Makes one line of code replaced, what is it? If I go back here, I don't need two event handlers. Okay, I'm back to just one event handler. That one line of code replaced 1, 2, 3, 4, 5 lines of code. So 5 lines of code with all its punctuation and syntactic overhead. That 5 lines of code got distilled down to one little line of code that says, when you click the button, do this. Yeah. When the button
Right.
gets clicked, here's who handles it. And
I got a
hmm, there's-
Sorry, I was gonna ask. So I know Action Listener only has one method in it, right?
yes. Hmm.
So then, this was a couple days ago. I was playing around with doing like the button click stuff. That has, I think it was five
No, not
different
button
methods,
clicks. What was like, uh
or it,
the mouse have 5 methods.
mouse listener. Yeah, that's what
Yeah.
it was.
That's the catch to this. You can't use this lambda. Okay, if you read the README, it'll point out that the catch is you can't use this lambda notation when you have to have 5 different methods, because then you don't know which method is which lambda expression. Java's trying to catch up with the functional people, and it's still got a ways to go. So you couldn't use the lambda expressions, right?
Right. So that was literally my question. Yeah.
Yeah. Then you hit the brick wall that you're hitting. You're really using an old-fashioned language, and you hit this brick wall that says, well, kind of, we sort of gave you modern functional programming, but not really. We kind of glommed modern functional programming on top of our language, but we haven't yet done a great job of it. So you can use this lambda notation because there's only one method in that action listener. Okay. But some action listeners, okay, over here, some action listeners have lots of methods. So even this one that has 2 methods, you can't make them lambda expressions. You've got to use the old-fashioned verbose notation of defining a class, defining the methods inside the class. You kind of have to use the old-fashioned notation. If you use a language like Haskell or ML or Clojure or Scala, they're truly functional programming languages. They have clever ways of dealing with this. Even if a event listener has four methods, you can still write them as Lambda expressions. You can't in Java, not yet. And I don't know if they even have an idea for how to solve that problem. Uh, right now, when the listeners are just one method, you can replace that one method with a Lambda expression. And Java calls them functional interfaces. See, functional interfaces in Java. Here's a list of the built-in functional interfaces in Java. We're actually using, when we do this little trick here, where is it? No. When we do this little trick here, when we do this little trick here, this guy is one of these functional interfaces. I don't even remember which one. All of these functional interfaces represent one function each. A functional interface cannot represent several functions at once. A functional interface can't represent a focus listener. A functional interface can represent an action listener, but not a focus listener. So if you even see the notation, they're using the word functional interfaces because it comes out of functional programming languages. And the traditional oh, here's functional interface. Okay. So Java's working on this. Functional interface. I'm sorry. See, this got added in Java 8, which in the history of Java is very late. That was about 10 years ago. That was about 10 years ago that they added this to the Java language, where they said, we really need to modernize Java. We need to head in the direction of these modern functional programming languages. Java 8, it's kind of funny. Java 8 added this stuff to Java about 10 years ago. At the same time, C++ created C++11. Actually, it was 15 years ago. They created C++11. They were doing the exact same thing at the exact same time as the Java people. So it wasn't 10 years ago, it was about 15 years ago. Java 8 and C++11 came out at the same time, and they both did the same thing. They added this functional interface stuff to their language. And it was a big watershed in both languages. They now call Java 8 and anything after it modern Java. And they call C++11 and anything after it modern C++. Java is now up to Java 25, and C++ is now up to C++. I forget what it is now. But what they're doing is building on this functional interfaces. They're building on the functional programming aspects of what they added to the language. C++11 is really different than classic C++, and Java 8 in a lot of ways is really different than classic Java. If you look at the textbook we use for teaching Java, it is based on Java 8, but it doesn't cover this functional stuff. If you look in your data structures book, it probably uses Java 8, but probably doesn't talk about this functional stuff. But if you go out in the real world of Java programming, more and more Java programmers are using this functional stuff. It's actually starting to get pretty common. It's starting to get to be a pretty big part of the Java language. It's taken a while for people to get used to it. If people were not taught functional programming in their past, they find this very weird. But if people have learned a functional programming language, then this feels much easier. Okay? So over here, now the J shell lends itself nicely to this functional programming because you don't have to type as much. See, I can just type one line of code in the J shell. Okay. Now go back over here to the J shell. See, what I did was I copied and pasted that line. I want you to see the mechanics of it. I highlighted that bunch of code. I just copied and pasted into the J shell. Now, here's what's nice. I can tell you to add another button. Here's another little block of code. Okay. So copy and paste that code. Oh, this uses the more verbose notation. See, this one line of code here, I'm going to add a second button, but the second button is going to use the more verbose notation. It's going to say, here's my class that carries the handler method. And then and then I'm going to create an instance of that class and add that instance to the action listener. So here's the 5 lines of code that were, yeah, that this one line of code takes care of all this 5 lines of code. Now, to use this 5 lines of code, I need to import a new bunch of classes. I have a button handler here, which didn't even need to import anything new. Now I need to import awt.events because I need an action listener and I need an action event. And so I need to import some more stuff. Okay, so now highlight this, right click, copy, go over here, paste into the shell. So what I'm going to do is I just control V into the shell. Well, I have to go to this window, control V. No, no, it's not working. Actually, what I'm going to do is I right click. Okay. Okay. Now, the J shell executed those lines of code. See, I have 2 buttons now. See, the lines of code. And now, if I want it, oh, now notice that the last line of code didn't get executed yet. Remember, that's why I want to show you the mechanics. The last line of code doesn't have a new line after it. I actually need to make sure I execute the last line of code. Here's my buttons. There's that button. There's this button. I'm still in the J shell. I can ask, what code have I run? There's the code I ran. The first 10 lines of code were the first time I pasted in. Then the next few lines of code were the second time I pasted in. If I want, I could pick. Now, if you go over here, there's another little block of code I can keep add. What this is going to do is it's going to add a third button back to the, oh, this is a nice little chunk of code that's intermediate between this very terse 1-line code, this very verbose code. This is the code that's called the inner class notation. It creates the event listener in fewer lines of code. Instead of defining a class, instantiating the class, and then adding the instance, I add a instance of the class all in one notation. It's actually a halfway step between this code and the Lambda expression. Okay, it's called the inner class notation. Okay, well, actually, it's called the anonymous inner class notation. This guy here that I've highlighted there, that's an anonymous inner class. Okay, so starting from here, the word new up to that closing brace, that's what's being added as the event listener. And this is the Lambda expression. Eventually, you just manage to you turn that guy into the Lambda expression. Okay, so highlight this, copy it. I'm going to add a third button. I paste it into the J shell. I need to I need to execute the last line of code. Okay, now I got 3 buttons. This button's using a Lambda expression. This button's using an explicit class. This button's using an anonymous inner class. So you see, you have 3 buttons with 3 styles of code here. Okay. And then this README goes on and says, okay, here's a 4th button that's back to the anonymous, the Lambda expression. So I did that just so you could kind of see in one place full-blown verbose, intermediate verbose, very terse. Okay, there's the 3 styles. An explicit class, an anonymous inner class a lambda expression. Okay, so they have names. This is class notation, anonymous inner class notation, lambda expression notation. And Java's not done. It's actually got other notations. There are static class notations, nested class notations. Java's got a whole bunch of ways of doing these things. But right here, you see three different ways of instantiating classes: explicit class, anonymous inner class, lambda expression. Okay, tricky, but I want you guys to see this stuff. I want you to see real Java programming, the way it's done in the real world these days. Java programmers bounce between these notations. They use this notation when they have to. Remember we said if your handler has more than one method, you've got to use the old-fashioned notation. Well, actually, if your handler's got more than one method, you either have to use the full-blown notation or you can use the anonymous interclass notation. You can use this notation with uh with two methods. Because once you've got this new action listener, you can define as many methods as you want in here. So this intermediate notation works with any event handler. The lambda notation only works with the handlers that have one method. Okay, now go back here. Let's now add another kind of object. Okay, now we're going to add a J checkbox. This checkbox, if we go over here, the checkbox does item events. Now, item events, luckily, are still one method handlers. Okay, so we can still use a lambda expression. So we create a checkbox, add it to the GUI, tell the GUI to rebuild itself. We set the size of the GUI. I just wanted to make it a little bit bigger so you could see it. You don't have to really do this. When you pack it, it'll pack it to the minimum size that works. This just makes it a little bit bigger. Then here we add a item listener that's this lambda expression. Okay? Now we're adding an item listener to the checkbox. So we're back to this picture. Now this is a checkbox which holds item listeners rather than action listeners. And now the event that's delivered to the checkbox is not an action event, it's an item event. Okay. Now let me do it. Take this block of code, right click, copy. The beauty of the J shell is you get to watch things happen as you do them. And then you can also experiment with them. Like at this point, I can add more code. See the button, notice it just appeared up there. I'm using a flow layout, so this stuff will flow if I wanted to. Okay. Notice if I click this box, nothing happens. Why does nothing happen yet? What happened to its event handler?
You haven't added a carriage return, so it
Yeah,
hasn't been
and
entered.
notice that's the goofy stuff. You got to be really careful with this stuff. There's the event handler. It didn't get a carriage return added to it when I did the copy and paste. If I look over here, notice that the carets at the end of that line never got executed. So this guy doesn't have a handler yet. If I go down here and I execute that last line, he's now got a handler. Okay? You got to be real careful. You have to be on your toes when you're doing this kind of programming. Stuff really matters. Now, here's something that's kind of fun. Checkboxes can be manipulated from code. If I, there's that checkbox. Set checkbox true. See, look up here. See, the checkbox just unchecked itself and I generated an event. This line of code, when I execute it, will check the checkbox. But when it checked the checkbox, you get an event. Notice that this is generating mouse clicks by code. This trick here is used by test programs. This is how you test GUIs. You can write programs that click on the items in a GUI using code. Now, if you do this with the buttons, what was the button called? I think check. go back to my code. What was the button called? Yeah, J button. If you select the J button, nothing happens. But J button does have its own way of being affected. It's called the J button has a what was it? Do click. With a J button, you do click. Kind of, yeah. Um, why didn't they say do check here? Where do they come up with these goofy, random almost names? I mean, they do kind of make sense. You set selected true, set selected false. What they instead of saying do select true or false, they say set select. But here you do click. Now, when I do click, if you watch, the button pressed itself momentarily and you got an event. Okay. So down here, if you watch, you can do this yourself. When you hit enter on do click, the press me button's going to activate. Okay. If I do my other button, button two, I can activate it, or I can activate button three. Okay. The funny thing is that do selected on a button isn't a compiler error, isn't a programming error. It just doesn't do anything. Okay. The set selected doesn't, it has no effect on a button, though if you run it, it'll work, but it just doesn't do anything. And I don't want to, oh, what about do click on a checkbox? Does it work? See, this thing lets you try it. So the checkbox, can you do click on a checkbox? Yeah, it just, whatever the checkbox is, it just changes it. Okay, so it toggles the checkbox. So you can still do click. So on a checkbox, you can either do click or set selected. Set selected true makes it in the check state. Set selected false makes it in the unchecked state. Do click just toggles it. So on a checkbox, do click keeps toggling it. Okay. So you can play around with this in the J shell. That's the nice thing about J shell is that you can watch things happen. Okay. So um, we've just covered this section 6 on event handling, the Java event model. So on Wednesday, we'll start this section here and then start that bleeds into the model view controller method. So these two sections kind of go. This just said, what's an event? How do you make it fire? And doesn't tie the event to any GUI. This starts tying events to GUIs so that when you click on a button, something happens in the GUI. Things get even more complicated at that point. Okay, anybody have any last second question? Um, I if I can't have office hours today, but if you send me if you want if you have questions, you can always send me an email. If you have questions about the homework again, if you have questions about the homework, send me an email about it. And hopefully Wednesday we'll be back in class as normal. Okay. Any last questions? Anything? Okay.
The homework is still due next Monday, correct?
Yeah.
Okay,
So
cool.
if you have questions about it, please, send me, come to my office hours. I'll be in my office tomorrow. The snow's pretty much removed from all the streets already. I'll be in my office tomorrow, and you can come and ask questions, and yeah. So, okay, all right. So I'm going to end the. I'm usually when we have these Zoom meetings, it's being recorded. I can put it up on the course website. I'll try to, if I can remember how to do it. So later today, maybe a recording of of what we did today will be up on the course website. Okay. So if I can remember how to do the recording, I put them up on YouTube. If I can remember how to do that, I'll put this recording of this up on YouTube and I'll put a link to it on the course website. Okay. So I'll end the message. Goodbye and have a nice day. Oh, how do I get
All right.
out of here?
Bye,
Have a nice day.
Bye.
Bye.
I don't even remember how to get out of this.